Hi, I'm Cary Bran with PLTLabs here at Plantronics. PLTLabs is the innovation engine behind all of our next generation wearable proof of concept prototypes, both in hardware and software. And we are so excited to be able to finally share with you a lot of the great work that happens here within the labs. Part of that work involves building wearable concepts. And today I'm very excited to show you our Wearable Concept One device. It looks an awful lot like the flagship product that we build called the Voyager Legend, that has capacitive sensing capabilities that know if the device is on or off your ear. We use these today to actually direct audio, so if you're on a phone call you don't need to actually push any buttons, you just put on the device and the smart sensing capabilities answer that call for you. Similarly, if you take it off, the audio goes back to the device where it originated from. But building on top of that, the team at PLTLabs has put in a 9-axis sensing capability using an accelerometer, a gyroscope, and a compass. And what we've done with these sensors is we have allowed developers internally and eventually externally to take this device and integrate in head orientation tracking, where you can track a head in 3 dimensions, also the motion of the head as it's moving back and forth. We've got an MFI chip in the device to allow you to easily integrate it in with iOS applications. And we've also got a suite of APIs for this device to allow you not only to do iOS development, but to integrate it into Android, Windows, and Mac as well. So we're very excited about this device. And as I mentioned, it does do head orientation, but we've also got a couple of other goodies in this device. The first of which is it has a built-in pedometer. So you can wear this device around and track your footsteps as you're walking. We also have tap detection. So if you tap on the device plane here, you'll actually get an event that says a tap has occurred. And I think the coolest feature is the free fall detection. So if this device is dropped, or if you're wearing it and you fall, we send an event as well. So you can capture that and you can do some very interesting applications around that. So today, I would like to show you some demos of how this device could be applied, some of the concept work that we've done here within the labs, and also share with you where we think there could be some real-world applications for this device. Behind me is a screen of the sensing capabilities that this device has. Because it has a 9-axis accelerometer, gyroscope, and e-compass, we're able to track head orientation and motion in 3-dimensional space. The device also, just to show a couple of these capabilities, has tap detection. So as I tap the device, you'll see that the events are surfacing up on the iOS application. The other piece of this that is quite interesting is free fall. So if I were to throw the device and catch it, you'll see that a free fall event has just happened on the iOS device, iOS application. The way that the data is being surfaced from this device is through what's called MFI, or made for iOS technology. It's a chip that actually allows us to natively go over Bluetooth with our data. There's some advantages to doing that for such things as low latency type applications that require head orientation data. We can get very, very precise and a lot of data over that Bluetooth channel. To actually show this in action, I think, is probably the thing that you really want to see. We have a sensor page here. This is going over iOS, and there's an API that allows you to surface the device information in iOS. But I'm going to put this device on and show you how it works with an avatar. So why don't we see what that looks like. So I'm going to put this on. All right. So now that I'm wearing it, as you can see behind me, there is an avatar. This is an avatar that represents head orientation. Now, right now, it's not moving all too much because, well, my head isn't moving. But if I were to turn to the right here, you can see that the avatar is tracking along with my head movements. I can look up, I can look sideways. And as you can see, what we're sending is the data from this device, this wearable concept, to the iOS phone, and it's rendering the model here that you're seeing behind me. Now, this is a concept application, but the real-world applications or implications that you could do with this technology are still to be discovered. But some of the ideas that we've had at PLTLabs, we've thought about implementing custom gesture support. So if you were in a meeting, for instance, and your phone rings, or you get an instant message, it creates an event on your device, and it's kind of drawing your attention, but you could decline that or automate a message back to a sender by just simply shaking your head no. Or if you wanted to actually answer a call during a meeting, you could actually just nod your head yes and pick up that call. But we're leaving that up to the developers, up to the innovators to figure out. The other piece of this that seems like a pretty good application is gaming. So being able to take this device and actually integrate it into a game, so you have another control plane in your zombie shooting. So you can actually have the precision of shooting with your head orientation while your hands are doing something else. So integrating it into games is another natural extension for this. And the third one is augmenting reality. So what I'd like to be able to show you now is how we've taken the head orientation data, the compass information that's in the device, and we've mashed that together with the GPS coordinates on the cell phone that we're using here, and have rendered a Google Street View of where we are at. Now, I'm currently not broadcasting from New York Central Park, but what you're seeing on the screen is a representation of Central Park. So as if I look around, you can see that this augmented map is following my head movements. If I look up, I can see the skyline. If I look down, I can see the street. This is only possible by surfacing the data that's in this device and mashing it together with Google Street View. On top of just being able to control the experience of knowing where you are in the world, we can actually share that information through the cloud. So all of the head orientation information, the GPS information on your mobile device, we propagate that up to the cloud, and we have data streams that applications can subscribe to as a concept that can convey this information. So for instance, if I get a phone call from a friend that says that they're lost in Central Park, I could guide them by just looking at my mobile phone and seeing what they're seeing through the Street View. So that's it for our concept demos around augmentation and head orientation. And we really are opening this platform up for you as an innovator to come in and discover your own implementations of how you would take this technology and move forward. This one exercised the MFI chip that is on the device to allow the sensor data to flow over Bluetooth on your iOS devices. And how you integrate it and what you do with it, the possibilities are unlimited. Thanks.